Hey everybody, this is Gabriel Cardona. Welcome to the prototype edition of the Subnet podcast. As you can see, I'm here by myself today. In the future, I will be joined by my amazing co-host, the Don himself, Don Wanton. We have a lot of great guests lined up for you. We're planning on having Connor Daly as our first guest. He's the creator of Pangolin and one of the amazing engineers from Ava Labs. So as I mentioned, I'm here today by myself. This is the prototype edition. Really, I'm just trying to make sure I understand how all of this new hardware that I bought today works. So the mic and the camera and OBS and making sure they all fit together in a cohesive workflow. So please bear with me if the video is a little choppy or the audio is a little crunchy. I'm still dialing it in. If you're an OBS wizard, please feel free to reach out to me and let me know perhaps what I'm doing wrong, perhaps how I can improve. So I figured today I would give a presentation on the Avalanche network. And so I'm going to jump on over and do that. So as I mentioned, this is the prototype edition of the Subnet podcast. We're planning on doing streams once a week. We're going to interview different teams and companies and projects in the Avalanche ecosystem. And we named it Subnet because, of course, we anticipate there being thousands and thousands of public and private subnets, which all emerge into the Internet of Finance. And we think we're really well positioned to interview all of the amazing teams and companies that are on-ramping into our ecosystem. So before we get started, I recently decided to go back through all of my social feeds and all my email accounts and everything to try and get a sense of when was the very first time that I was talking about crypto. And this screenshot right here is actually the earliest screenshot that I could find. This is April the 23rd in 2012, and this is one of my real good friends, Dylan, from here in San Francisco. He was actually an engineer with me at my very first job out of college, and we've remained friends all of these years. And so a little bit of backstory. I initially found out about Bitcoin in 2011 on Hacker News. So I am a really big fan of Paul Graham and Y Combinator, and I used to be a daily reader of Hacker News, news.ycombinator.com. And in around 2011, somebody posted on Bitcoin, and I was immediately smitten, and I fell down the rabbit hole. And at the time, Gavin Andreessen, who is the engineer that took over for Satoshi when he or she stepped away, had the first ever faucet, and he was giving away 5 full Bitcoins per drip. So of course today it's very common to go to a faucet and put in your crypto address and get some free crypto to on-ramp into the ecosystem. But at the time, this was new, and I certainly had never seen anything like this. And as I mentioned, he was giving away 5 full BTC with each drip. I have always heard, I don't have, verification from Gavin on this, but I had always heard that he gave away 50,000 full BTC through that faucet. And I was interested, and recently I actually went back and found the address and checked it out on a block explorer. And it says that that address has transferred 70 or sent 75,000, over 75,000 full Bitcoins. Now that doesn't mean for sure that he gave away that many, because of course you can send them back and forth, and there's ways to pump that number, but still, I think Gavin probably gave away a life-changing amount of Bitcoin. Had he held on to it today, of course, it would be worth over $1 billion. But perhaps Bitcoin wouldn't have taken off like it did had he not initially planted that seed. And so we all owe Gavin a great debt of gratitude. I actually still remember the first 2 characters of my very first base 58 check encoded address ever. It actually started with the number 1717. So, as soon as I found out about Bitcoin, I fell down the rabbit hole. I was definitely like a religious zealot, and I told everybody I knew about it. I was super, super stoked about it. But as you might imagine, this was 2011, and there was not a ton of opportunity in that space. And at the time, I was a young father. I had a baby boy at the time. He was probably around 1, my son Solja. And so I decided to pivot, out of the very, very nascent and early Bitcoin ecosystem into working at Trulia.com. And so I was at Trulia.com for the IPO, the initial public offering on the New York Stock Exchange. That happened in 2012. And so the screenshot you see here is from about 3 months before that. And of course you can read it, but I'm going to go ahead and read it as well. So Dylan says to me, Trulia is going to make some coin, to which I reply, that's the feeling I get. And he replies, ain't going to be no Bitcoin neither. And of course I say, lols, Bitcoin, those were the days. So I just think that's funny because, again, this was in April of 2012. So what do I really take out of this slide? Well, it just reminds me that I really was around in perhaps not the very, very beginning, because, Satoshi kicked this whole thing off in 2000 and 2008, 2009. But I still feel like I was there very early, and it feels very fortunate and auspicious to have been a part of the ecosystem at that time. But I think more importantly, what I pull out of this is simply that friendship comes before crypto tribalism, quite literally in this particular screenshot. So, we all know that crypto is extremely tribal. It's like taking the very best of politics and the very best of religion and sprinkling, fast money on top. And so it really does bring out the very best in people, /S. So this slide is a reminder to me, to myself, that, friends come before crypto tribalism. So I like this slide, and I think it's pretty funny. But now, of course, I think we can just dig into, what is Avalanche? So, Avalanche is a global financial network for the issuing and trading of all digital goods. And we enable potentially millions of validators to process thousands of transactions per second, and with near instant finality. And we do that using a protocol which is completely green and quiescent. And we have paired this, very high throughput, extremely fast finality protocol with an architecture which can meet the needs of unique financial products and decentralized applications. And we accomplish this through this notion of subnets. So subnets allow anyone, anywhere on Earth, to spin up a tailor-made network with custom virtual machines and complex validator rule sets. And so, what is Avalanche? Well, Avalanche is a network of networks. It is a platform of platforms, and we envision thousands and thousands of public and private subnets all emerging into what we are calling the Internet of Finance. So before we talk about exactly what Avalanche is, I think it's useful to give a brief history on the evolution of the blockchain revolution. I suspect that most of the information in these next couple slides won't be news to anybody who's watching this right now, but in my own personal life, I've discovered that if I really want to appreciate where I'm going, it really, really helps if I truly understand from where I've come. So, blockchain 1.0. Bitcoin is blockchain 1.0, and Bitcoin proved to the world that there was a need for a robust and a decentralized payment network. And though it started out its life as peer-to-peer electronic cash, for better or worse, that's simply not what it ultimately grew into. And, I will be the first to admit, having gotten into Bitcoin so early and having been so driven by that vision of peer-to-peer electronic cash in the beginning, I was myself a little bit salty for a long time that that's not quite what it matured into. But, it's been 10 years. I've matured a lot in that time, and my viewpoints have definitely, grown. And I've actually come to realize that it's okay that Bitcoin, the base layer, BTC, of course I understand about the Lightning Network and all of that, but I'm talking about the base layer of Bitcoin. I think it's actually okay that it did not grow into the peer-to-peer electronic cash. Number one, there are 1,000 other cryptocurrencies which now handle that particular use case. But more importantly, I think Bitcoin really did still grow into something incredibly powerful, and that is, it is a hedge against inflation for the mom and pop investor. And so without falling too far down this rabbit hole, inflation is basically theft, right? A lot of people say taxation is theft, but I think with taxation, you can at least justify it because, you can say, well, the taxes are used to pay for the things we value in our society, right? They pay for the utilities, they pay for the streets, they pay for the fire department, they pay for the police, they pay for the military. But with inflation, it's just your money becoming worth less every year. And so something that's really big is that 1 out of every 5 US dollars, 21% technically, of all of the US dollars that have ever been printed in the entire history of the United States were printed in the year 2020. And that's a red flag for several reasons. Number one, the purchasing power of every single person who's watching this their purchasing power of their dollars has decreased about 20%. And I'm sure you feel it. I live in the San Francisco Bay Area, and the prices are absolutely going crazy. I recently read that if you make minimum wage in San Francisco, so it's $17, $16 and some change. If you make $17 per hour in San Francisco right now, you have to work 4.9 jobs. So let's say 5 jobs. You have to work 5 full-time jobs in order to afford a two-bedroom apartment in San Francisco. Obviously, that's not practical. And so that just gives you a sense of really the purchasing power of the US dollar decreasing. And so where I will end with that is this idea of hyperinflation, right? So I'm certainly not saying America's entering hyperinflation right now, but what I will say is that printing one out of every $5 in the last year in a country that's over 200 years old is in fact a red flag. And if you don't think hyperinflation can happen to you in your lifetime, look at Zimbabwe, Greece, Venezuela, Argentina, etc. Hyperinflation absolutely does happen in the modern world, and there are plenty of people all around the world who have had their entire life savings wiped out by hyperinflation. And so it's something to be aware of. But I think the big takeaway point here is that Bitcoin and other cryptocurrencies allow you to opt out of inflation. And so trust me, your kids will thank you for that. And so, Bitcoin has had a radical impact on the lives of many, myself included. And so, I always say that my wish for Satoshi is that Satoshi is still out there living his or her or its best life. I hope that Satoshi is happy and healthy and out there working on the next generation of amazing technology. That is what I hope for Satoshi, out of gratitude for the amazing way that Bitcoin has had such an impact on my life. All that being said, obviously Bitcoin is not perfect and there are some downsides. Number one, it's slow. So, again, on the base layer, I'm not talking about the Lightning Network right now. The layer one BTC network, it only does a handful of transactions per second. It takes about an hour for them to really be final, so that 6 blocks, so that you can be confident that it's not going to be reorged out from under you. It has a scripting language called Script. Some people say it's Turing complete. Some people say you can output like Conway's Game of Life. My personal opinion is that may or may not be true, but even if it is true, it feels more like it's just an interesting thing that it can do more than it's valuable in any practical way. And the reason I say that is that I've yet to see anybody using straight up Script on the straight up layer one Bitcoin network to build an automated market maker or a distributed exchange or a DeFi app or a derivatives market or a distributed autonomous organization or a prediction market or any of the stuff that we see absolutely booming in the DeFi ecosystem. I've yet to see that really, really written with Script. So even if Script is Turing complete, it's incredibly awkward to work with and it doesn't feel modern at all. Another thing about Bitcoin is that it has tokens, but they're very, very primitive. So yes, I do understand that Bitcoin has an op return where you can write 80 bytes of arbitrary data to the blockchain. Bitcoin Cash has 220 bytes. I am aware that you can encode asset creation and asset issuance commands into that small amount of data, and that you can write wallets which pull it out and decode it. The problem is that these tokens are not miner validated. And so if you write a wallet to do this, you have to traverse the DAG of transactions all the way back to the asset genesis transaction. And then you've got to walk your way back down this data structure and confirm that every single transaction, every burn, every issuance, every sending was correct, that there were no double spends, that there's no funky business happening. That's incredibly cumbersome for developers. I myself have done it in the past. I built Badger Wallet with some amazing devs a couple years ago. So you offload this to a third-party service. We helped fund and create what was known as SLPDB, which is ultimately like a cloud service which handles this work for you. But that, of course, removes a big part of this whole decentralization which crypto gives us. So I am just a big advocate of miner-validated tokens, and Bitcoin does not have them. So as amazing as Bitcoin has, there were some shortcomings, and that is ultimately what led and enabled blockchain 2.0, and we consider blockchain 2.0 to be Ethereum. And so Ethereum is a decentralized app which allows developers to launch their own decentralized apps on top of it in the form of a smart contract. And the reason this is a big deal is because prior to Ethereum, if you wanted to launch your own dApp, you had to launch your own network. So that means you had to roll your own, you had to deal with your own security and incentive structure, you had to launch it, you had to achieve the network effects required to ultimately tip and go mainstream. And that was very challenging. Not many projects could do it, and it led to a very bespoke environment. By enabling developers to launch their smart contracts on top of Ethereum, it enabled a huge network effect. So that was win number one. and then having this whole idea of a virtual machine that you can then have a higher level, Turing complete, modern looking ish language. You know, Solidity's not TypeScript or Golang, of course, but it's a heck of a lot more modern than what you would be writing with script. And then you can compile that down to Ethereum virtual machine bytecode, EVM code, and then that led to a huge wave of innovation around tokens, initial coin offerings, NFTs, DeFi, yield farming, prediction markets, DAOs, Web3, and really so much more. I'm a huge fan of Ethereum, and I really have been since the very beginning. The very first time I read the yellow paper back in 2015, I believe, I remember being like, I was already a big fan of Vitalik then because he was a writer for Bitcoin Magazine, and he tried to do some tokenomics projects in the BTC ecosystem, and for whatever reason ended up launching Ethereum. And I think the world is actually better off for that. I'm a huge fan of Vitalik. I think he genuinely is one of the great thinkers of our age. He's still a young man, and I suspect his best days are still ahead of him and his team. You know, I give credit to where it's due. So Vitalik and his team, I'm very impressed with them. Now, we consider Avalanche to be blockchain 3.0 technology. And so similar to Bitcoin and Ethereum, Avalanche introduces a handful of new paradigms, which I'm going to go over right now. So of course, the first, of course, is Avalanche Consensus. So consensus is a very rich field of computer science that goes back around 40 years. And we think of Avalanche Consensus as the third major paradigm in consensus. Next is Network of Networks. So unlike traditional crypto networks like Bitcoin or Ethereum, where you have one virtual machine and one set of miners or validators, Avalanche is actually a network of networks with compound network effects, and we'll talk about that in a second. Third is virtual machines. So you can think about virtual machines are like the application level logic of your blockchain. And so instead of defining your dApp as a smart contract in Avalanche, you actually define your dApp as a virtual machine, and you're not limited to a language like Solidity. You can use Golang or really any language which can write to this gRPC API, which we have. And then last, subnets. So as I mentioned, subnets allow anyone anywhere to spin up a tailor-made network, and they can have custom virtual machines and complex validator rule sets. And so those are the four paradigms that we're going to be talking about. I see that my video is getting chunky here. I'm not entirely sure why that happens at this far in the stream. I'm not sure if my CPU or RAM is getting all busted up or what exactly is happening, but I do see it. Let me see if I can make any difference if I do this. I'm just going to put a pause on the presentation for a second because the whole idea behind this talk was that I'm going to dial in my equipment. So yeah, I think I'm not entirely sure why at this point the CPU spikes so hard. It definitely has to do with open broadcasts. I'm using Streamlabs. I'm not entirely sure. I'm going to try and optimize that later. But I do want to go ahead and finish this presentation despite the fact that my video is choppy. I'm actually going to turn it off so that it's not distracting if anybody's watching. Thank you for allowing me to try and debug that. I'll get it dialed in a bit later. So first, let's talk about Avalanche Consensus. So you hear consensus a lot when you work in the blockchain industry. You hear it 1,000 times a day. So what exactly is consensus? Well, consensus is the process by which a series of independent validators come into agreement on a decision. So that's it, basically. How do you get a bunch of different people to agree on something? Is this transaction valid? Is it invalid? Is this color orange or is it blue? That is known as consensus. And it is a very rich field of computer science. It goes back at least 40 years to the 70s. And we think of Avalanche Consensus as being the third major paradigm in this space. So we have this really nice comparison chart here where we compare classical, Nakamoto, and Avalanche. So as I mentioned, probably in the 70s and 80s, about 40 years ago, classical consensus emerged. And classical consensus has very high throughput. It has extremely fast finality. It's very lightweight. It's green, but it's not scalable and it's not robust. It's not decentralized. All of the different validators in the sets need to know everybody else, and it performs poorly in adversarial conditions. In 2008, 2009, when Satoshi dropped Bitcoin, it actually never says the word consensus anywhere in the white paper, but a lot of the original industry professionals, academics, computer science, mathematicians, hackers, all of these people initially sort of knew whenever they were reading the white paper and studying the code, hey, this is an entirely new type of consensus. And so sort of teased out of that was the name Nakamoto consensus, which is what it has been come to have been known as. And so Nakamoto consensus is very scalable and robust. It's incredibly decentralized, but it lacks all of the upsides of classical consensus. It has very slow throughput, a handful of transactions a second, low finality, low latency. It takes about an hour to be confident your transaction is not going to be reorged. It's not lightweight, it's not green. So we've all heard the meme of BTC churning through more energy every single day than some nation states. Though to be fair, that's actually not a problem in my opinion in the long term. It is in the short term because we're not yet completely renewable on our energy. But I'm a big believer that the future of the world, the systems will follow biomimicry. Basically, we will develop sustainable systems. And so, for example, every single hour, enough energy falls onto the earth in the form of sunlight to power the entire planet, 100% of our needs, including biorenewable, fossil fuels, and nuclear energy. Every hour, we get 100% of our energy needs for a full year. So, once we can harvest the sunlight, sorry about that. Once we can efficiently harvest the sunlight, store it, and then transport it, then we'll have infinite energy. So it's not really a big deal, in my opinion, that Bitcoin churns through a bunch of energy, although it is today, of course, because we don't have 100% renewable energy. But in the future, that will not be a problem. Sorry about that. Neighbor and his motorcycle. Okay. So, and then also Nakamoto is, performs okay in adversarial conditions, up to 51%. Now, in around 2017, 2018, a pseudonymous group of people under the name Team Rocket released a white paper on the IPFS introducing an entirely new class of consensus called Avalanche Consensus. And technically speaking, Avalanche Consensus is a metastable consensus protocol which is inspired by epidemic protocols and gossip networks. And the way it works, the process used to determine if a transaction is preferred or not is referred to as repeated random subsampling. And Avalanche is a perfect storm of the very best of classical and the very best of Nakamoto consensus. So it's very scalable and robust. It's extremely highly decentralized. Today on our mainnet, we have right at 1,000. I think we literally have 994, 995 full block and vertices producing validators. We can validate multiple blockchain data structures. So there's a linear chain, and that has blocks. Blocks are groups of transactions. We're all familiar with that. We can also validate what's called a DAG, a directed acyclic graph. This is a different type of data structure that only has partial ordering, and instead of having blocks, it has what are known as vertices. So a vertex is to a block as a DAG is to a blockchain, right? So a vertex is simply just a collection of transactions. Like I said, we have about 1,000 full block and vertices producing validators on the mainnet today. It takes 2,000 AVAX that you have to stake in order to be a mainnet validator. Our intention is to lower that number over time, and theoretically, Avalanche Consensus could have millions of validators. Of course, that's a theoretical limit. It's not been proven in the field, but it's something that we intend to push the limit on as much as possible, certainly and most especially as the Internet of Things comes online. Next, Avalanche Consensus has extremely high throughput, thousands of transactions per second, very fast finality, oftentimes less than a second. We say 3 seconds on our website, but I have seen it take 20 milliseconds, 50 milliseconds, about as long as the blink of a human eye, quite literally. Avalanche Consensus is extremely lightweight and green and quiescent. You can run it on a MacBook, you can run it on a PC, you can run it on a VPC droplet out on the cloud. And it's it performs very well in adversarial conditions. So it's parameterizable. It can perform above and beyond the 51% attack that Bitcoin is susceptible to. And so that is Avalanche Consensus. Next, I want to talk about the second paradigm we're introducing, which is network of networks. So I have a really great slide here. I want to give a shout out to CryptoSec, who's an absolutely brilliant individual that I found out about on Twitter, who just has a very great breadth and depth of knowledge across the entire blockchain space, not just Avalanche, but across many different decentralized and blockchain technology stacks. And I really have a lot of respect for CryptoSec. If you happen to see this, I really, really like your work. And so I pulled this graphic from a CryptoSec Medium article. It just really sums up exactly what I'm going to try and express here. So As I mentioned, Avalanche is slightly different than traditional crypto networks such as Bitcoin or Ethereum that have one virtual machine and one set of miners or validators. So Avalanche is a network of networks with compound network effects. So let's explore that a little bit. We've all heard of network effects. What is that? Technically speaking, that is called Metcalfe's law, and it says that a network's value is proportional to the square of the number of nodes in the network. So for example, if a network has 10 nodes, its inherent value would be 100, right? 10 times 10. So in other words, a product or service gains additional value as more people use it. And the canonical example of this, of course, is the telephone. If only one person on the planet has a telephone, it's not that useful. If two people have a telephone, it becomes more useful for each of them. And for every additional person that plugs into the telephone network, the entire network gains in value for every other person because everybody can call everybody else. Another great example of a network effect is, of course, cash. If only I accept AVAX, it's not really that useful. But for every other person on the planet who accepts AVAX for a good or a service, it increases the value of the network for everyone because everybody who holds AVAX can use it to buy and sell anything they want, any good or service, right? So that's the network effect. A product or service gains additional value as more people use it. But there's sort of like an extension to that called Reed's law, and this deals with compound network effects. And so Reed's law says that the utility of large networks, particularly social networks, can scale exponentially with the size of the network, as the number of possible subgroups grow much more rapidly than either the number of participants or the number of possible pair connections. So even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. And so if you look at this chart, for example, you can see that there's the Avalanche network down there, and then there's a bunch of these different little subnets, including our primary subnet, which we will discuss briefly in a bit. So even if the utility of each one of those different groups is very low on a per group basis, eventually the network effects of all the potential group membership can dominate the overall economics of the system. And so Avalanche's subnets are really designed and primed for compound network effects. Next is virtual machines. So a virtual machine defines the application level logic of your blockchain. And technically speaking, it specifies the blockchain state, the state transition function, the transactions, and the API through which users can interact with the blockchain. So every single blockchain that runs on the Avalanche network is an instance of a virtual machine. And you can kind of think about it like object-oriented programming. So if you're familiar with object-oriented programming, you know that you define a class, and that's like the blueprint of your objects, and then you instantiate the class into different instances of the object, or different objects, instances of the class. And so even though all of these different objects may follow the same rules, they are all logically independent of each other. And so it's the same thing in our world. The application level logic of your blockchain is a virtual machine, and you can instantiate that virtual machine into many different instances of the blockchain. And though they may all follow the same rule sets, they are logically independent from one another. And as a developer, if you write your dApp as a virtual machine, you don't need to concern yourself with the lower level logic like networking, consensus, or even the structure of your blockchain. Avalanche does this all behind the scenes for you, and we provide you a best-in-class suite of APIs to do, like I said, direct acyclic graphs or linear blockchains, peer-to-peer payments, smart contracts, anything you want, and you get networking consensus out of the box. So why would you want to create a VM? So blockchain networks that only have one virtual machine have a predefined static set of functionality. This is very rigid and monolithic, and it limits what can be run on such networks. And so again, anytime you want to run something like in a custom decentralized app, you really have to roll your own. And so that often leads to, limited security and sort of a very bespoke environment. Avalanche's virtual machines make it easy to define blockchain-based decentralized apps. And rather than new limited languages like Solidity, you can actually write your VMs in Go today, Golang, or we have a gRPC API, and if your language can output to that gRPC API, you can really write your virtual machine in any language. And the way that works is You can run your virtual machine in a separate process than the main Avalanche Go process. And we have a special virtual machine called the RPC chain VM, which basically runs your virtual machine in a separate process. It wraps it as a server and exposes it over a gRPC API that then launches a client within the main Avalanche Go process that can call into, make RPC calls into your VM. And so that's the way you can basically write a VM in a non-Golang language. And so lastly, I want to talk about subnets. So again, as I mentioned, a subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. And if you remember, a blockchain is an instance of a virtual machine. A virtual machine can be instantiated into many different blockchains. Each blockchain is validated by exactly one subnet. A subnet can validate many blockchains, including many instances of the same virtual machine. And a node can be a member of many different subnets, some public and some private, validating many different blockchains, including many different instances of the same virtual machine across these different and public and private subnets. So from that data visualization, you might get a sense of exactly how heterogeneous and rich and diverse in character the Avalanche network is. And so subnets manage their own membership. They can require that constituent validators have certain properties, and this is very useful, and we're going to explore that a bit right now. So the first would be compliance. So Avalanche's subnet architecture makes regulatory compliance totally manageable because subnets may require that validators meet a certain set of requirements. So for example, you could say every single validator in my subnet needs to be in a certain physical legal jurisdiction. They all have to be within the United States. Every single validator in my subnet needs to meet certain KYC AML requirements. Every single validator in my subnet has to hold a certain professional license, for example. And just to be 100% clear, regulatory compliance and private subnets are optional. You also have the option to do completely permissionless and public subnets. Our stated goal is to build the Internet of Finance, and we appreciate that traditional finance is thousands of trillions of dollars, much of which is wrapped in regulatory compliance. And so we want to, again, provide a best-in-class suite of APIs and SDKs, which empower people to launch completely open and permissionless networks, all the way to completely private, permissionless, and regulatory compliant networks, and everything in between. So we have support for private blockchains. You can create a subnet where only a certain predefined validators can join, and that's basically a private subnet. And the contents of the blockchains will only be visible to those validators. Of course, this is ideal for organizations interested in keeping their information private. Also, there's just simply separation of concerns. In a very rich and heterogeneous network of different types of blockchains, some validators are simply not going to want to validate certain blockchains because they really just don't care about them. They have no interest in those blockchains. The subnet model allows validators to only concern themselves with the blockchains that they care about. And this ultimately reduces the burden on all of the different validators. And then there's also application-specific requirements. So, of course, different blockchains require different blockchain-based apps may require validators to have certain properties. So suppose there's an app that requires a large amount of CPU or RAM. A subnet could require that validators meet certain hardware requirements so that the dApp doesn't suffer from lower poor performance due to slow validators. And so quickly as we close up here, touching on subnets, when at the Avalanche mainnet launch, we launched with our own primary subnet. We asked that all validators validate the primary subnet. So anybody can launch their own subnet, but in order for a validator to validate that subnet, they have to be validated on the primary subnet as well. As I mentioned today, it takes 2,000 AVAX. We're going to be lowering that in the future. We have 3 blockchains that are live on our primary subnet. We have the X chain, which is for exchanging assets. This is a DAG, a directed acyclic graph. This is an instance of the Avalanche virtual machine. You can launch your own instance of the Avalanche virtual machine on a subnet today and use non-AVAX assets to pay the fees. The X chain is where AVAX was issued. AVAX is a fixed cap asset. There will only ever be 720 million AVAX. We use it to pay fees across the network. We burn it for fees, therefore creating deflationary pressure upon the asset. You can launch your own Non-fungible tokens of collectible style, you can launch variable and fixed cap assets. And what's really cool is that you can move these assets back and forth between these three chains. We have cross-chain swaps built into our core protocol, and in the future we will have cross-subnet swaps. So in the context of this compound network effect idea, you'll be able to move assets and data back and forth, not only between the chains on one subnet, between the different subnets as well. So that's going to be incredibly powerful. In the middle, you can see we have the platform chain, the P chain. This is a linear blockchain, and it's used for, coordinating validators, creating subnets, instantiating virtual machines, adding delegators, that kind of thing. And then on the right, we have the contract chain. This is an instance of the Ethereum virtual machine where we removed Nakamoto consensus and we plugged in Avalanche, technically Snowman consensus. Snowman consensus is like a sister protocol to Avalanche consensus. Avalanche consensus operates on DAGs. Snowman consensus operates on linear chains, but they have the same properties: extremely high throughput, fast finality. And then anything that works in the existing Ethereum virtual machine, any of the DeFi, any of the workflow, Hard Hat, Truffle, MetaMask, Remit, etc., works out of the box in our ecosystem. So if you have an EVM DApp on any EVM network, Ethereum, Binance Smart Chain, Matic, Polygon, whatever, you can just drag and drop it into our network with very, very minimal changes, and you'll get all of the wonderful properties of Snowman or Avalanche consensus out of the box. Extremely high throughput, fast finality, immutable, irreversible finality in about a second. So unlike Nakamoto consensus, where you can be reorged, that is not a concept in Avalanche consensus. In Avalanche consensus, when you have finality, it is immutable. It is completely irreversible. So that is our primary subnet. So I want to thank you if you made it this far. Again, the primary idea here was that I was going to dial in this workflow. As you can see, as I bring back the video, it still seems like it's pretty choppy, so I've got to sort of debug that. But overall, I'm very happy with the gear I brought today. The mic is nice, the camera is nice, the light is nice, everything is good. Just got to kind of dial in my OBS workflow. So again, if you're a OBS wizard, please reach out to me. So again, my name is Gabriel Cardona. You can reach me on Telegram or Twitter at CG Cardona. Thank you so much for listening. Cheers.